How's everybody doing?
Yeah, I to you, but Mother Nature just kind of dying out, I guess. Anyway, I think maybe we'll cross the antennas again when we have a little better conditions. Single bender 347 downtown Manchester, Tennessee. Looking your way, I'll be off the key.
Well, hello to you, 347 Manchester. Operator Justin trying to get up in your receiver around Manchester, Tennessee. 347 DX1 call.
I hear that 347 DX1 555 Clearwater, Florida.
I was saying hello to 347. I'm in Oklahoma, man. I'm Justin, DX1 Radio, but I was saying hello to Manchester.
I hear that DX1 555 Clearwater, Florida.
Hello, 555 Clearwater, Florida. Hello, 555 Clearwater, Florida, DX1 Radio.
They're coming in good here. I'm off that Galaxy DX95T2 with the
All right, man. Well, it's working. I told you. It's working for you, man. Hey, the 95T is a good radio, bud.
Thanks for coming back. Have a good day. 555 Clearwater, stand by.
Absolutely. If I had one Galaxy radio to recommend, the 95T is one of the better chassis. Yes, sir. That's one of the better radios. The 86. But anyways, that 95T is a good one, man. Anyways, take care.
Have a good one there. Thanks for coming back. 555 Clearwater, stand by.
All right, 555 Clearwater, Florida. This is Oklahoma DX1 Radio. Justin standing by. Absolutely, man. Delta X-Ray 1 over here. DX1 Radio in the lab. How's this audio sound on this transmitter? You go listen to AM. It's going to be okay. You guys are all sounding good, man. 9-pound hammer. Operator Justin. Hello to you guys out there around the northeast corner. 9-pound hammer, Oklahoma.
Oh, yeah.
That's right. I just wanted to ease up in there. I wanted to ease up in there and say hello to my friends. Hope everybody's doing well. Radio station 9-pound hammer, Oklahoma.
Gotcha. Weak.
We're just goofing off. Hello, JG Mopar. Hello to you, Mopar. Mopar. JG Mopar. Break up, break up.
Which one was doing it? I think what topped it off on why it blocked me, I sent him a video of a professional apologist. And he didn't like what he heard. And then he took me. Same way here. I hear they're running. When the radio come on, I hear payment. Been here spanking the last couple of days. And sometimes I hear Kim out. I hear him in there first time.
Hello to you around the 20. I'll say hello to you around the 20. Oklahoma. Oklahoma looking great.
Yeah, Roger.
Hey, what you guys doing out there? Hey, what's going on? Oklahoma waving. I'm on a big antenna. Hey, Roger, I'm just waving, man. I'm just playing around on the AM transmitter. Just wanted to say hello to you guys. Hope everybody's having a great one. Radio station 9 Pound Hammer. Working this little radio right back.
I don't know. I'll try, but I ain't making any promises.
Mopar, where are you at? You got a beam to point out here? I'll come up the sideband. Let's see if you can get my radio.
Yeah, what's up? 312.
Delta X-Ray 1, Northeast Oklahoma. Down here playing around. What's going on the 385?
I still can't believe it's not product.
Hey, I just wanted to see if he's out there, man. No problem, Mopar. Take care. DX1, take care. 76. Operator Justin, Oklahoma's DX1 radio, live in the lab, working his Skywave. Hello to you around the 385 radio station DX1, Oklahoma, standing by.
How about the Oklahoma station? 830 on Ontario, Canada, on site.
Absolutely, 830. We hear you. I had another station right before you, but they're kind of. I'm looking up towards New York, kind of up towards the northeast. So I'm not real, But anyways, 830 DX1.
What's your QTH?
I'm in Oklahoma. I got the beam pointed a little bit northeast though, so I'm not right on you there. But hello from Oklahoma. Hey, QSL. Yeah, I've got a lot of other signals that are down coming in on the side, but we definitely have you, man. You're sounding good. Operator Justin here in Northeast Oklahoma.
I didn't quite catch that name again there. The first one here is the old dog. Who would you say you were back to?
My name's Justin. Juliet, Uniform, Sierra Tango, India, November. Justin, back to you, Bill.
Okay, Justin, we got you that time for sure. Yeah, you're not too strong. We do have a copy on you. Well, I'm not going to hold you up. We're trying to make some other contacts there. So we do appreciate you coming back there from Oklahoma. Yes, 1 Oklahoma, 830 Ontario. Thank you very much. Have a good day, sir.
Absolutely, 830 Ontario. That's what it is, man. You're a little bit north. I'm not looking north enough to get you up there in Ontario. But I'm just splashing you a little bit. Keep up the good work. 830 Radio DX1, Justin, Oklahoma, standing by.
7317. That's what you said. Anything, 830 Eastern Toronto. We say 73. You're talking to my guy all wrong. It's a wrong call. Do it again. A stab in the face for a salary guy.
I don't know if any of you guys seen my sampler I built, but I'll fire up everything. I'm not doing nothing anyways, but I built a pretty nice sampler. I'll let you see it. So the sampler's right here. That's that box. And I'll fire up everything. I need to turn it on anyways. And then we'll fire up the 1040. Let everything come up to temperature, and then I'll show you what we got going on. That was move, Dad. Yeah, and then it'll fire up. I don't know if you can see any of that stuff yet. Give me just a second. Now all this stuff here. Oh, my boom's dropped. Move, 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 move. How's everybody doing? Just playing around in here. Doing good. Almost ready to call it a night. Oh, God. 4 a.m. Anyways, if we go over here, I can do it easier if I just take this plumb out of the boom. I don't know if you can see any of this right now. Oh, yeah, you can see it. Hello, 676. I don't know if y'all can see that. Oh yeah, you can see it. You can go to channel 20. That's good for around in here. Kind of waiting on my wife to get home. I just turned this on, so gotta let it warm up. It's true analog. This is a really cool setup. See it in my phone. I'll zoom in on it, and it will. Yep. Cool beans. That's pretty wild to me. I don't. Oh yeah. It's just the phone wants to be a dick. Wants to be a dick. There we go. I'm just trying to give it a chance to zoom. I'm just showing you the. I say in a second I'll walk away from it. I gotta come back down here and show it to you, but. Seven bird. I run my reference down. It's -9. About 7.8. I should be pretty close to the reference. Ooh, still tall. 5.8. Okay. Now the bottom machine's getting nice and warm. And we got that right to the top. That's beautiful. But look how beautiful the bottom is now. It'll zoom right in on there. There you go. Yeah, I'm just warming everything up. Letting it sit. And that's a big carrier. On channel 20, top right hand corner of the screen. It's because I'm holding it with my hand there. I don't have nothing in the boom. And then over here, you got your RMS. Down here, you got RMS. I'm in average right now. That's what I meant. But if I go to the 50 watt scale, put it in TEP, watch that 50 watt scale. Oh! Oh, I've got my transmitter turned way down. Yeah, it's 30 peak. I turned the transmitter way down. I'll show you what I mean. Well, I can't do all this with my damn hands full. But we can key it and turn it up to 10. Now we're on. It'll key big. Like, so there's 15 watts carrier. Remember, we're on AM. Now watch the 50 watt scale. We'll go average. Obviously, the carrier won't change. Still swinging forward. Voice. Oh. Oh. Oh, I got the mic gain. I got the mic gain and everything turned down. But all right, so now we got. There's a 15 watt carrier. So I'll roll that 15 watt carrier down to 2 divisions. Come on, Justin, you gotta unkey the radio. I gotta unkey it. Do it again, and then we'll get there this time. So there's 2 divisions. So if we come down here, turn the 1 kilohertz tone on, and we'll modulate that to 100%. And of course, we come over here now and turn this into 100 watts because it's going to bury. So on the tone, it's doing, as you can see, pretty damn good average. I'm just goofing off. Turn the tone off. I know I'm making you guys dizzy as hell. And then on a tone, on a modulated PEP on a tone, we'll watch the screen. I'm gonna, down here. It's doing, with the radio power set where it's doing 60 watts right there. And that's what the mic gain turned down. So it's a cool little setup. What I was showing was the sampler that I built. Let me set this in my damn booms. I want to set my transmitter up for a lower power ratios. So what I'm going to do now is we're on a 100 watt scale. We're on a 100 watt scale, which it means you're reading the bottom scale, 20, 40, 60, 80, 100. And then you're going to, over here, so we're going to turn it down to level 5. Give me about a 7 watt carrier. Let's see if I've got this memorized. So I'm going to go to 10. We should see about 7. I'll be down. Just about got this memorized. So I work with all this every day. All right, so now I'll take you back over here and show you what I'm talking about. It's a really cool little setup. If you've never seen the 1040. I think you can see everything from there, and you just trust what I'm telling you. I'm not going to lie to you. So we're going to go to the 10 watt scale. Back here behind you, I'm going to leave it on a 10 watt scale. This is all RMS behind me. So 10 watt scale. Check out what we do. So we're going to go to set, reflect. So we set that, reflect. Then we're going to turn 1 click past. That's going to say read the load. Then we can go read the reflect. It's pretty cool stuff. It's all very accurate. $50 scale. Set it. Ready to load. 1-to-1. Here's what this looks like when it's nice and warm. It's beautiful. That's expensive, son of a bitch. Over here, I'm going to show you this whole reflex setup, how it works. It's all very accurate stuff. So we're going to go SWR, forward, SWR. So we're going to go forward. We're going to go SWR, reflect. You see what I'm saying? That's going to give you the measurement. If we go forward, we set it to set, which is the red indicator. It's not quite there. I went too far. I just want you guys to see it. Okay, now we're going to flip this switch down. Sorry, you can't. I'm not showing it to you. This is going to read the reflect. Ready? 1 1 1 1 1 1 1 1. 1 1 1 1 1 1 1 1 1. We're reading the reflect on a 10-watt scale. What does that mean, Justin? So you're reading the 10-watt scale. Full deflection. So this is 1 watt of reflect. 1 1 1 1 1 1 1. 1 watt of reflect would be right here. That's less than a nano gnat's ass of a watt of a reflect. What do I mean? Well, let me show you what I mean. Come back over here. Go through the same scenario. Forward power. 7 watts of RMS. Set reflect. Reflect is set. Read the reflect. 1.01. So literally under 1-to-1. Well, what do you mean under 1-to-1? Well, that's what I mean. Come over here. And we're going to ask the radio to sweep the SWR. Ready? That's what I mean. That is a 1.0 input. What does that mean? What am I saying? What am I showing you? I'm showing you that the RF sampler that I built yesterday is built. I've tuned and specialized the circuit and optimized the circuit so that the dummy load doesn't even know, the RF sampler doesn't even know that anything else. Basically, let me rephrase. The dummy load doesn't know that the sampler is even present. So what this is showing you is that this is properly designed. Because if it wasn't properly designed, it would be changing the impedance. Me fastening this piece of equipment in between the input of a extremely expensive top-of-the-line dummy load that is extremely commercial, right. It's not seeing this. Well, it's because if you watch the video, I built the 50 ohm shunt circuit inside here. And this is a true toroidal sniffing RF sampler design that I built. It's at a negative 40-50 dB. Then from there, coming out of there, I'm going to go into the spectrum analyzer, and then you see we have another attenuator circuit That goes right there. All this stuff does is keeps the front end of the spectrum analyzer, which is a very, very sensitive piece of equipment, keeps it all happy. I'm just making sure I got them clipped. I'm in the dark, and I'm not in the dark, but I wasn't standing up. I didn't make sure. That's how all that works. And if you look up here, you can tell that the RF sampler is built and designed right, because if it wasn't built and designed right, the oscilloscope wouldn't be setting at 0 voltage with a probe applied to the circuit. Now, number two, a lot of you are going to say, well, you just going to got the scope set on the offset to hide anything. Well, let me show you that I don't. So if you look right here, we go to probe, turn the probe on, and then we're going to go next page, and you see offset. And you see it. There's 0 voltage. Do you see the 0 voltage on the offset? Now look at where the oscilloscope's tracking. At 0 voltage. What does this mean? This means that the scope probe is not picking up any DC. Meaning that my RF sampler is properly designed. Because when you build an RF sampler and you don't build the circuit properly, what it will do, as soon as you hook the probe up, you'll see the offset load the probe. And what's happening, guys, is if you have too much DC on the probe, you're heating the probe up. Well, if the probe's got a 1 megohm resistor inside it and a decoupling circuit. But if you're getting external DC on the line, it's going to make this yellow line crank way, way up. And then whenever you go to put the carrier on the screen from your transmitter, it's going to run off the screen. And anytime you see that, you're loading DC on the probe, and you're got a problem. Things can go bad real fast. Now, there is some circuits that when we probe, it's going to load the circuit. But in a circuit like this, to where we have a set $50 ohm impedance and everything is balanced, no matter what we hook, no matter where we touch in this circuit, we should have isolation, which is what I'm showing you here. So if I key it up, you can see, and I'm even going to turn this to 2 divisions, and you can see it is super clean. I have to pick it back up for you to see anything because I got you at a wrong angle. See, guys, you're all sitting way down low, and all the equipment's up here. And for me to get you up here to where you have the right kind of view of what's going on, you got to be at my eye level. But have you seen? Isn't that not a clean? Any technicians in here? Is that not a clean scope signal, guys? I'm pretty proud of my sampler, if you can't tell. To go buy a sampler, inline sampler, you know how much they cost? A good one, a high quality one that works at a high watt ratio. I mean, it's tall. I can't even talk. I'm getting tired. Can handle a lot of wattage. And is this clean? I mean, I'm pretty damn proud of it. Oh, test 1 2 3 4 1 2 3 4 1 2 3 4 5 4 3 2 1. Now you can look and just see how beautiful. Y'all ever seen a analog scope? So what's going on here, guys? This is an analog scope. This is a 8553B top section, 110 megahertz spectrum analyzer. And then we have a complete IF section, which is all this. So basically, this is filter selectivity. This allows me to set references and set what I want, where I want. It's basically set filters and set reference and noise floors. Be able to look at the signal and measure the signal and amplitude over frequency, or it's frequency over amplitude, however you want to say it. So it's going to tell you where it's at, and it's going to tell me how tall and how strong the signal is according to what reference levels I have set it, if that makes sense. I'm just trying to waste time. My wife's bringing me something cold to drink, if you know what I mean. Oh, I didn't finish showing you everything. So this would be on. And this is my freak counter. So that would read out my frequency. Of course, I have one built in all the other equipment. And then I set the spectrum analyzer for a center frequency on which I'm talking on. And then, as you can see, and then when I key the microphone, if you look at the top right-hand corner of the screen, you'll see the frequency of operation. 27,000,2050. If you come over to the radio, look at the radio, you'll see we are transmitting on 27,2050. If you look over at the piece of equipment, it tells you we're transmitting on 2050. Just everything so you can look at, when you're doing the stuff that we do here, you got to have something that's accurate. This here is a bench top. I've never really showed my bench like this, so I'm just showing you what it is. Some of y'all might like it. I need to back up a little bit. I'm sorry. So down here is the BNK. This is the 2831D. This is a true RMS benchtop multimeter, and that does all kinds of stuff. This will read frequency. This reads ohms, amps, AC, amps DC, voltage DC, voltage AC, voltage DC, up to 2,000 volts DC, and up to 2,000 amps DC. Pretty now. This active line's a 20 amp effective, so I can measure right off my bench meter. I can measure a pretty strong amp load, up to 200 watts, 20 amps. So, but I wanted to show this whenever it's up to tip. I mean, look how beautiful that is. I absolutely love that piece of equipment. I love it because it's an antique. Guys, that's almost as old as I am. Not quite, but almost. It's got a built-in calibration output. So if you look at the bottom there, it's basically if I take my BNC cable, plug into that negative 30 dBm, that's going to give a 7.1 microvolt signal at 30 megahertz. And what that signals for is to calibrate. So if it wasn't calibrated right, you take that signal, put it into the front end of the machine. Then you'd go to the right mode of operation. And what would happen is you would see the 30 megahertz signal. You'd see the second, third, fourth order of that signal, which is what that's going to show at 7.1 microvolts, negative 30 dBm. So you'd set your reference level for a little higher than that level. Then you could look, and what you can do is set. See how it says 7.1 microvolts? So whenever you get this big tall peak, you're going to count 1, 2, 3, 4, 5, 6, 7, and then you're going to have 1.1. So the peak of the 30 megahertz signal would come up to about where my thumb is. And if it didn't, then you'd come over here and you adjust your vertical. Actually, for that, you would have to determine that the output amplitude is right, which all this is calibrated. Even though it's old, it ain't like up to 2026. Like, I'm not going to sit here and lie. It's got stickers all down the back. And the last active calibration that I know has been like in 2024. So, I mean, it's 2 years. The freaking 2 years it ain't been calibrated, which it ain't done nothing but sat here. And I'm telling you, it's accurate. And then I use these for, like, say I'm working on something. You can basically take this piece of equipment. Now that ain't supposed to be over there like that. Of course, it's got auto sensing. But I use that benchtop one when I got something over here. Like, I got something right here, serious I'm working on. Then my leads, I can take them over here. But for the most part, I can just grab that little handy duty. Not this one. This one's for a complete different thing. If I'm going to use something like a hand multimeter, I'll use my Fluke. Because that will do plumb down to the smallest amount of picofarad to the largest amount of microfarad. That is an expensive son of a bitch. Those are over $400 for that meter when it was new. Not bragging. I'm just telling you that the good stuff costs. Like that thing right there is expensive. Holy shit, is it expensive? And this thing. And this thing. But you gotta have them. And this. You'd be surprised what these will run you. This hobby is so expensive, guys. And I mean, if you're gonna set up a decent little lab, man, you're gonna spend a little bit. Like, I don't even know what you can get a 2040 and a 1040 for now. I don't know what that stuff's going for. I bet a complete set that's working is over $5. I bet. Especially one that's, in good shape, that's functioning. I really sure like it. It's really helpful, especially when you do the receiver stuff. How you do the receiver stuff is this input here. I just made this little jig, or this little lead. This is very high quality audio cable, but anyways, it's the receiver audio feed. So you take this blue cord here and plugs in to the BNC and then goes into the speaker jack. Then you'll take this cord, which is over there, put it into the back of the antenna jack. Then you'll turn this on and then go to channel. I use whatever the specs call on the alignment procedure, but tune this to whatever. Then you send the modulated signal or whatever amplitude that you want right to the transmitter. And the way this is designed, it's preset for like CB radios, because these are all basically our preset values. And the way this is determined, instead of having to come up and look at your amplitude scale, like on that, you'd have to, I got it turned off, but you'd have to set and turn it. This has preset scales, so like negative 70 dBm, negative 80, 90, all the way down to negative 120 or negative 120, negative 110. So, and then your typical negatives in between 70 and 60, negative 67 dBm, F9 at 30% modulation, 1 kilohertz. That's, your typical that we use. Just all the goodies. Guys, I'm going to get off here. My wife is messaging me something. And I'm going to look at her message. Thanks for watching. Thanks for hanging out. And yep, that's the RF sampler. Custom DX1 built sampler. Dual port sampler.